Hey everybody, this is Ricky with SimpliPhi. Can you guys hear me out there? Feel free to type in. Okay, good. All right, so now we're filing in. So Josh, I'll let you take it away whenever you see fit.
Hey, this is Josh, the products manager from Wholesale Solar. We had scheduled this training with SimpliPhi originally for our employees, and then we kind of shot it out on the to our installers to see if anyone was interested in attending. Basically, we're really excited about lithium batteries and SimpliPhi's product. It eliminates a lot of the issues around batteries. So we're really glad you're able to join us today. Wholesale Solar is an off-grid distributor, so basically we can help you. We supply SimpliPhi batteries, and we can also help you with inverters, panels, controllers, any other components. With that being said, take it away, Ricky.
So we got a lot to cover here. We might not have time for a whole bunch of questions, but we'll get some information at the end, how you can reach Wholesale Solar, get your questions answered, should you have any. And special thanks, Josh and Wholesale Solar. It's great to be here with a company that has a lot of experience. From my early days in solar and in renewables, I definitely turned to Wholesale Solar, and I know I still to this day use a lot of your tools on your website, like for peak sun hours, which comes out great when I'm trying to design battery banks. So awesome to be here with you. My name is Ricky Sklanowski. I am a sales and applications engineer at SimpliPhi. Among other things, one of the primary things I do is tell you whether or not our batteries are suitable for certain applications. What I'm hoping you'll see from this training is that it almost always is. So on the agenda, I'm not going to read through each bullet point, but we have kind of like a mid-level overview of SimpliPhi's product line and value proposition, and what really differentiates us from some of the other industry leaders out there. Okay, so specifically SimpliPhi, we are the safest, most efficient, and simplest way to use energy storage. So what that means is we have the safest chemistries, unparalleled cycle life, and easy to deploy and install and scale systems. And what you're looking at right there on your right is our access unit, and we'll get into that a little bit later. So SimpliPhi optimizes any power generation source for on or off grid. So whether it be grid or PV or a generator, on or off grid, we can do it. We can do it. So, and one of the things that we do that differentiates us from our competitors is that we can DC and AC couple our systems. So Sonnen, for example, only has AC coupling systems. So here's a map of where we're deployed over 22 countries as it reads, 27 megawatt hours since 2010. We actually started in 2002 as Ojai Electric Systems, and then in 2010 became SimpliPhi, and we started off in the film and TV industry, and then became really popular with with the Department of Defense and being used in military applications. So you can see Iraq and Afghanistan has been highlighted here. We're known with the Department of Defense really like this because we could be deployed into some of the harshest environments in the world. So here's our customer base, and what you can see is that it cuts a wide path. We don't really have a prototypical customer. There are all kinds of applications, as I said at the outset, for our storage systems, and that is kind of evidenced by this customer base. You can see in the bottom right quadrant some of those military applications I was alluding to. Residential, we have some small local installers, and then in the top left quadrant, utilities, LADWP, and then of course we have some emergency response customers as well. And here we have a graph showing our expected market growth, and by our I mean everyone on this call. The energy storage industry is set to experience exponential growth, estimated about $2 billion by 2020. In fact, our revenue tripled last year alone. Note how evenly split it is amongst the light blue, which is residential, the darker blue, which is non-residential, and utility, which is the darkest blue there. So that means no matter which space you're primarily involved in, there is an ESS application for you. I'm getting some notes here, so let me just see. So again, I just want to double check everyone can hear me out there. Okay, great. Someone was having problems hearing, and I just didn't know if it was applied to everyone. I want to make sure everyone can hear. All right. So here is probably the most common notion of how storage can be utilized. So you bank your solar production, shown in light blue here, and you bank that during the day, and then at night when the sun goes down, you can utilize that energy that's been stored in your batteries. And that's what we call priority power. And then storage can also be used for rate-based consumption. So what you're looking at right here is kind of a typical rate schedule where during peak hours, shown by the orange there, you're charged a higher rate on your bill, and kind of around those kind of afternoon hours or your mid-peak, so that's like the medium part of your bill, and then in the early morning and late night hours, you're charged the lowest rate on your bill. So I know most of the people on the line are probably from California, and we're all familiar with NEM 2.0 here in California. So storage is taken on, has become increasingly favorable because of NEM 2.0. You have to, now if you get solar and PV, and pardon me if this is remedial for a lot of you, but you will be forced to switch to a rate-based schedule. That is if you are in one of the investor-owned utilities. So what you can do to offset that is you can use your PV and your battery bank to discharge during the times when your bill is most expensive. So you can offset your bill, just making it lower. So an example of this would be if it's a hot summer's day and you got your AC on full blast, you can drop your batteries during peak hours to again offset the most expensive part of your bill. And we call that rate arbitrage or time of use optimization. You might see those two terms used interchangeably. And then you got peak shaving, which there's a kind of a cool graphic of kind of what that is. And if you want to see that in a different format, here's another way of looking at it. So this is really, again, in California, and not only in California, but especially here in California, commercial entities in C&I space are charged demand rates. And so what that means is that they're charged based on how much instantaneous power they're demanding at any given point in the day. And it's measured in kilowatts. So think of a good way to think about it as a factory that's running at full capacity at noon. So we'll say that the peak of this graph represents noon. So storage allows you to draw off your batteries in order to reduce the demand charges. So instead of paying a rate at that blue peak that you see at the apex there, you can instead pay a rate at the red line. Again, thusly reducing your bills. So here is a representation of our product line. It's not our entire product line. You can go to SimpliPhiPower.com to see the entire product line. So what you're seeing here is our mobile plug-and-play line to our fully integrated solutions, to kind of our core products, which if you look at the battery in the very top with the red and black terminal, I call that our standard battery. That's our Phi 3.4 battery. I know many of you are familiar with that battery. Right below that is our Phi 2.6, and right below that is our low profile battery, which is can be put under floorboards and tight spaces, and that's also a 2.6 kilowatt-hour battery. The bottom left is kind of an interesting piece of equipment there. It is our power bank, and it's used a lot in emergency response scenarios. It's been used in schools, in homes, and in hospitals. It's kind of like a mobile turnkey solution. And the access as well, again, we'll get into that, is also a turnkey solution, and we'll talk about that in a moment. So here you see our kind of our core products on the left there, the Phi 3.4 and the Phi 2.6, which, you know, given that we're talking to Wholesale Solar and their customer, these are the batteries that you will be most interested in, I presume. So what you're looking at in this video is a lead acid replacement. And this is kind of our bread and butter. This kind of differentiates us from other lithium-ion manufacturers. You can keep your existing equipment and install our batteries, do a small reprogramming of existing inverters and charge controllers, and you get a 10-year warranty, 10,000 cycle warranty as a replacement for your lead acid batteries that will most likely last no longer than 5 years. And it's as you can see, it's a lot. There's no maintenance involved. The batteries on the left, the lead acids, it's a mess. It have to be water replacement and valve regulation and things like that. So it's a lot simpler. It's a lot neater, and we'll talk more about that in a moment. So here's some basic parameters of those two core products that you can see here. We'll just let you glance at that for a moment. And on the batteries themselves is our battery management system, or BMS. So the BMS is a passive system that basically just keeps the cells happy. It's passive in the sense that it doesn't require any extraneous electronics or internet or anything else for it to work. It works autonomously. And it can protect against those things you see listed there. And it also has a circuit breaker for overcurrent protection. And as you can see, it's an 80 amp breaker on the Phi 3.4. And it effectively works as an on-off switch, which it's turned off during shipping and it's turned off during installation. The breaker works in conjunction with the built-in BMS and creates additional safety, efficiency, and functionality to the overall power storage system. So you'll hear a lot of, if you've ever talked to any of us here at SimpliPhi, we all know this diagram and why it's important. So this is something that, you know, maybe requires a little getting used to. It certainly was for me, is that our batteries are always wired in parallel. So it's not parallel in the sense that you're going negative to negative to negative or positive to positive to positive parallel wiring. It's the type of parallel wiring that's shown. Note how all the leads head straight up to the positive and negative bus. And all those conductors that you see there must be of identical length and gauge. So here's one of our favorite pictures. I know it's one of mine. So what you're looking at is the initial installation in 2013 on the left. And then on the right, you can see just 2 years later, they doubled the size of the bank. They increased the capacity twofold. And one important note that you should see here is note the orientation of the batteries in the right-hand side photo on top that are upside down. That will not void the warranty. It's just another example of how easy it is to install our batteries. There's less restrictions. Additionally, you can't see it in this photo, but they could be butted up against one another. These are using our wall mounts, which we also sell separately. They could be laid on their side. That's perfectly fine. So any way that's practical to install these batteries, and even in low ventilation spaces, is totally fine. And this kind of, and to add one more point, doing this type of increase in capacity with lead acid, for example, is a lot more complicated. When you're adding to series battery strings, the aging units will limit the viability of the new batteries. So we're going to get into the access unit now, which is kind of our plug-and-play turnkey solution, whatever you want to call it. But it still uses the same great batteries, those 5 3.4s. They come in 2 varieties. You can either get 2 of those batteries, or you can get 3 of them installed in the compartment that's pictured in green on the access unit. And if you were to open up that cabinet, you would see that the batteries are installed side by side, right next to each other, and you don't have to worry about any heat or off-gassing or odors or anything like that. So the problems with conventional energy storage systems, you can kind of see right here, you kind of got to get all these pieces piecemeal. You got to get them one by one, and you got to have a lot of know-how on how to configure everything. And to reiterate, you know, there's a longer design time. Often they're indoor rated only, like Sonnen. I'm picking on them a little bit. You have to have the multi-day installation, and if you're not trained, I know you haven't done several of these before, multiple items and a special training. But with the access, we actually program it and install all the components here in our factory. So you could just plug and play. There is currently a Schneider 6840 inside the unit. You can DC or AC couple. It's NEMA 3R rated for outdoors. No maintenance and super safe with those LFP batteries, lithium iron phosphate batteries. Okay, so what you're seeing inside the box here are some of the core components that you can get inside the actual access box. So certainly you're going to get that Connect inverter and charger. You're going to get those batteries. And if you're DC coupling the system, which is what's pictured right here, you can get a charge controller. That MPPT unit is a charge controller. And at the top of the box, you can see the optional automatic generator start and the COM box. So here's a typical example of DC coupling. The modules head to the MPPT unit and the inverter and work to charge the batteries. Now that is different from an AC coupled array, where it goes into a sub panel or a critical loads panel and then can be used to charge the bank. So you can come in multiple directions. Now some of you guys might be thinking about California Rule 21 compliance. The Schneider is not yet Rule 21 compliant, but within the next couple months, we will have this outfitted also with an Outback 8048 radiant inverter. So that inverter is Rule 21 compliant. So if you're in one of those investor-owned utilities, you can look at that as an option for you. One interesting thing that I should add about this, another differentiator, is that you can actually AC and DC couple at the same time. Just keep in mind there's a 6,000 watt or so inverter inside, so you want to size accordingly. But there's no reason why, if you size appropriately, that you can DC couple and AC couple at the same time. Okay, so common question that comes up is, what kind of warranty do we offer? And we do believe it's an industry-leading warranty. It's a 10-year warranty, and it's for 10,000 cycles. If you go to 80% depth of discharge, which we recommend, or a 10-year 5,000 cycle warranty. Now, important distinction should be made is whichever of those comes first. warranty will end. So if you hit 10,000 cycles before 10 years, the warranty would end at that point. Now, this is, again, best in business. If you are, in the middle of the screen, you see our 80% end of life. So what we're saying there is that at the end of the 10 years, where you're expecting to get 80% of the initial capacity at the end of 10 years. Now, most of our competitors won't put that on because it's kind of a bummer. It's kind of a thing that they don't want to talk about. But 70%, just so you know, is what most of our competitors are doing. So at the end of 10 years, we're saying that you're going to get 80% of the 3.4 kilowatt hours that you initially got, and that's roughly about 2.72 kilowatt hours. All right, so we're going to learn a little bit about lead acid to start and show a little bit of a lead acid comparison. So lead acid comes in a lot of different styles depending on the application. Some aren't heat tolerant, some are better at deep cycles, some are sealed to prevent gassing, some are cheaper than others. They all, however, are high maintenance and short-lived, and usually less than 5 years of life on a lead acid battery. And they're all low on capacity when compared to our lithium iron phosphate battery. Now, likewise, there are also different types of lithium-ion batteries. Some may be better than others based on the application. And then there's other ways to store energy too. You can store fuel cells or with capacitors, flywheels, hydro recapture, etc. So there's a number of ways to hold or to store energy. So our focus for this next session will be on the lithium family, as you might have guessed. So when talking about lithium-ion, two of the things we like to talk about are form factor and chemistry, and we're going to get into why that's important. So these aren't the only types of form factors, mind you. There's other kinds like button cells and things like that, but these are the most common kinds in our applications. And so the three kinds, as you can see, cylindrical, pouch, and prismatic. And here are the most common types of lithium. And you may be noticing already some commonality between those chemistries and some of the elements that make it up. And those are, and here we have it highlighted for you. A common element amongst in the lithium family is cobalt. So once again, here's another differentiator. We don't have cobalt in our batteries. Instead, we use the lithium iron phosphate, as shown in green. So what are the problems with cobalt? Many of our competitors use them. LG Chem and Tesla, Powerwall, to name a few. The problem is maybe the most important thing is safety, and so thermal runaway is a safety issue. And we'll talk about thermal runaway in the next slide. But another problem is rapid depletion. At about 500 cycles, you're going to see rapid depletion of those cells. Super narrow temperature window. They're toxic and they're inefficient. So at SimpliPhi, we address those four major issues: safety, life cycle, temperature, and environmental impact. And so let's get into that. Okay, so when you hear in the news about Samsung Galaxy Notes, hoverboards that kids got for Christmas, Teslas or Boeing Dreamliners catching on fire, that's the result of a very volatile element, and that element is cobalt. Cobalt-based batteries are prone to thermal runaway, which is essentially a positive feedback loop with an exponential and uncontrolled heat rise in the battery. And here's an example of the Boeing Dreamliner on the right catching on fire. Not good when you're up there in the air and the things catch on fire. approximately 500 cycles for the cells prior to rapid depletion. Now, we can all relate to this. So actually, my wife just got a new cell phone yesterday, okay? So I'm at the end of my 2-year plan on my phone. So I have to do more frequent recharges on my battery than my wife will. This is something we can all relate to with a laptop, with a cell phone, or what have you. The battery wasn't the same when it was brand new. So when you're talking about narrow temperature windows, we'll just call it out right there, 23 degrees to 104 degrees Fahrenheit. It's in that you have less applications to work in. Certainly in colder climates and in some hot desert climates too, that won't work out too well for you. Certainly in Southern California, we've been experiencing hotter than 104. So cobalt is less temperature tolerant. So here you see examples of using coolant and heat sinks to some extra ancillary stuff or equipment that you don't have to use with our chemistry. So let's take a look at that 23 to 104 degrees Fahrenheit in the next line and compare it to what we can offer. So our operating temperature is at -4 degrees Fahrenheit to 140 degrees Fahrenheit. No need for coolant or special HVAC equipment or ventilation. Now this should be distinguished from the charging temperature. You don't want to charge the batteries below freezing or above 120 degrees Fahrenheit. So the next question I can imagine coming up on the screen is, well, what do I do if I'm in a cold climate and it drops below freezing? So some of our installers use heating elements to warm the batteries. They can attach a temperature sensor to it, a battery temperature sensor, or you can install it if you have a battery bank room and use some heating in that room as well. So there's a couple ways around it. So a huge problem with cobalt is that it goes straight to landfills, and it's been linked by the EPA to a lot of health problems, respiratory problems, cardiac effects, congestion of the liver and kidneys. It's a toxic element. So our LFP chemistry can be recycled. There are third-party recycling companies that do recycle our batteries. Our batteries are 98% efficient. Now, Tesla states on their website that their cobalt batteries are 90% efficient. So there you see the difference. So getting into the form factors now, we can talk about some of the pros and cons of each form factor. Every single form factor does have its pros and cons. So we can just kind of discern which one might be the best. Okay, so we're going to talk about pouches first. They're super lightweight and flexible. They can be stuffed into a box or an enclosure is probably the better term for it. Much easier. But the cons is that they're super temperature sensitive, and they can swell when they see a heat rise, and in worst case scenarios even burst. And those cells have less capacity. So the prismatic cells are often called a happy medium. Maybe that's true, maybe it isn't, but we'll let you decide. So they're thin and flat. They have great space utilization. So you can imagine you can fill a box with those prismatic cells pretty easily without any air pockets. They do have a shorter life cycle. Inside, if you were to open up one of those, it's a lot of thin separators in there, like these thin paper-like separators with a little bit of electrolyte. And they're prone to crystallization to some extent, and there's poor thermal management. So we use the cylindrical form factor. Very stable, difficult to short out, since they are circular, we know that the circle is the toughest of all the shapes. So they have mechanical stability and they're difficult to break. And like I said, they're difficult to short, and they're great at cyclability. The problem with the cylindrical form factor is that they're heavier, and they create space cavities when inside the enclosure. And a good way to think about that is a box of soda filled with soda cans. You're going to have some air pockets in that box. So here's what our competitors are doing. So LG Chem is using the pouch. Tesla uses a cylindrical form factor. However, they use a cobalt cell. The problem with these and it's a smaller cell than the kinds we use. And here you can see the cells pictured. The problem with smaller cells is that there's more opportunity for failure, lots of points of failure, and additional heat discharge as electrons pass through. So these batteries are designed for consumer electronics, and really putting them in solar applications and cars, probably not the best idea. These are, by the way, Samsung cells. But by taking smaller cells and scaling them into residential, commercial, and utility settings, Tesla is scaling hundreds of thousands, if not millions of cells with toxic thermal runaway risks, thereby scaling up the associated risks and hazards of lithium cobalt chemistries. So as stated previously, we're using the cylindrical cells. They are larger than Tesla's and not designed for consumer electronics. We have less cells in our batteries, and our LFP chemistry isn't prone to thermal runaway. So we're just, simply stated, it's a safer battery. So speaking of safety, we're going to talk about shipping, and you'll be happy to know that we are approved for all modes of transportation globally, including air. When you do ship, it is required, however, that you use shipping labels, special shipping labels like the ones you see here, and a hazmat certification is required. See, because the Department of Transportation doesn't distinguish between the different types of lithium-ion. So they don't care, or maybe they don't even want to care that we're an LFP chemistry and not a cobalt-based chemistry. So we're seeing a little bit of a change in that, in the hearts and minds of for example, some of the fire codes are loosening. I know in New York City, for example, where they used to not allow lithium ions, they're starting to allow them in. So, and it's based on chemistry, and we have a few deployments going into the city. So when talking about, when you're talking about sales, you really want to talk about the true cost of the system. So what is the true cost of the system? Or put it simply, what's the cost of every kilowatt hour I can get out of the system? So an easy thing for anyone to understand is upfront cost. You know, that battery costs X amount and that battery costs Y amount. But that's not the true cost of a battery. So spoiler alert, we're not as cheap as lead acid batteries. So how do you convey that to a customer when they're shopping around? So here's a simple formula. So the price, that upfront cost, goes as your numerator. And then in your denominator, you have to do you have to multiply a few things together. So capacity, certainly we have much better capacity than a lead acid battery. Multiply that by the number of cycles. Again, much better than a lead acid battery. Multiply that by some other derates. A common one is temperature. So again, cobalt-based chemistries, lead acid are much less tolerant to temperature. So how much you're going to have to derate for temperature. Times the depth of discharge. We recommend going to 80% depth of discharge. Some are less. So the lower the depth of discharge, the more batteries you're going to have to buy, the more capacity you're going to need. So these are important things to consider. They're not the only thing to consider. You want to consider the ancillary costs. So what are some of the ancillary costs or hidden costs? You know, do I need to designate a special room in my house for all these batteries? So there's a square footage and installation location consideration. The weight of the batteries. That's going to increase your shipping costs. Do I need special equipment? Do I need to do any cooling or any special ancillary equipment for cooling? So as you can see here, I'm not going to read through the whole list, but there's often these hidden costs that are associated with other systems. Okay, so here you can see a graph that was brought to us by Lazard, where it shows cost savings, the actual cost, the levelized cost of energy of leaded acid versus lithium-ion. So residential, so here we have residential and C&I. So you're at least going to save $135 per megawatt hour with in residential, and at least $118 in the C&I space per megawatt hour. And that's saying doing it conservatively. You can see how much you could potentially save by the graph here. Not to mention all the headaches of having to have your lead acid batteries replaced and equalized, and all the other headaches that go along with it. So we're going to talk a little more about lead acid and just show some graphs. So here you can see our available capacity versus current. So you're going to see some rates of discharge at the bottom. It's okay if you don't understand what those mean right off the bat. We're actually going to get into that in a little bit. Generally speaking, you don't want to exceed a C/2 rate, but even if you did, the available capacity of our batteries is pretty uniform across all discharge rates. Okay, so here you're going to see why we warranty for 10,000 cycles. There's no significant loss of cycle life across a really broad temperature range. Cycle life is pretty much steady at 10,000. Okay, so the batteries from this graph, they don't struggle to charge and discharge. You can do so across a wide temperature range. Some people say that our batteries are quick charge batteries because they can charge in approximately 2 hours. So, not to belabor the point, but here's some of the key takeaways. Phi versus lead acid. No memory effect, no maintenance, simple integration, no ventilation, consistent performance, and a better levelized cost of energy. So system sizing. Here we'll learn a little bit about those C rates and a few other things. So real simple calculation. Somebody says, I need 36 kilowatt hours worth of storage. Here's an example of how you can calculate it. But in the next slide, we'll show you why that's typically not the way you do it. This is a simplistic way of doing it. The better way to do it is by pointing out that we really only want to take these down to 80% depth of discharge to abide by that 10,000 cycle warranty and 10-year 10,000 cycle warranty. So here's the actual calculation. You actually want to divide by 2.72, which is, as previously stated, 80% of 3.4. So in essence, 11 batteries, you can calculate it that way, but a better calculation would be 13 in this scenario. And the same holds true with amp hours. Sometimes, especially everyone who's familiar with the lead acid from lead acid days, they're normally designated by amp hourage. So you can do that same calculation, and additionally, you can take 80% of the 67, so 67 amp hours per 148 volt battery. For those keeping score at home, 80% of 67 is 53.6. So you can divide by, so 700 divided by 53.6, and that would tell you how many batteries you should use. So those are some simple calculations you can do with the calculator. We also have some more advanced tools that show some of the same things we're talking about. It does the same simple calculation, and it shows a few other things. And we have some enhanced calculators where you can even do a bit of array sizing and sizing for off-grid, and put in a few derate factors. So yeah, so this suffice to say that we have some enhanced tools should you need them. And of course, we can share those with Wholesale Solar. All right, so we've seen this graphic before earlier in the presentation. Same voltage, these are in parallel, these batteries. So it's the same voltage across the whole entire bank, but the current adds, and the amp hour capacity adds as you add batteries, but not the voltage. There it is again. You'll hear that a lot of times. So C over 2. It's actually a real simple calculation. So we're looking, so the C is your numerator, and that is the capacity of the battery in amp hours, and 2 is the time in hours. So the calculation is this. 67 amp hours is one 3.4 battery at 48 volts. Divide by 2, you get 33.5 amps. So what we're saying is that the max charge rate and the max discharge rate that you want to use is 33.5 amps for that particular battery. So the goal is to try to target that when you're sizing a bank to get the most longevity out of the batteries. If you absolutely had to do it, the max discharge current is 60 amps for that 48 volt 3.4. Okay, so this is another differentiator. If you were to compare this graph to a lead acid graph, it would look a lot different. It would look a lot more choppy. So this discharge curve illustrates the full available operating range for a 48 volt 5 battery. Note the smooth and continuous discharge curve. The curve at the left peaks up at approximately 58 volts and sweeps down and till its complete duration, which is actually 36 volts. But the actual useful portion of the battery is between 57.6 and 40 volts. Usually at 40 volts, we'll do a low battery voltage cutoff. So again, it's differentiating us from other chemistries. Most applications, especially off-grid, will engage a generator well before 40 volts, perhaps even 46 volts, or begin load shedding to avoid a system shutdown. So here is an example of a way of tracking state of charge. Certainly not the only or even the best way to do it, but it gives you an idea of some of the voltage ranges at varying state of charges. So if you pay attention to the right-hand column only for 48 volts to make it easier, you notice that 36 volts is 0%. So that's when the battery is done. And it needs, well, certainly needs a recharge at that point. But again, this would look a lot more choppy if it were a lead acid battery. And the voltage is pretty stiff. It remains pretty fixed, as you can see. just going to check some chats real quick just to make sure we're good. Okay. I'm always paranoid that people might not be able to hear me. So anyways, moving along. So we offer integration guides for the power electronics. We work really closely with Schneider. This is an example of a Schneider 6848, Outback, Midnight, and some of the other major manufacturers out there. And we have integration guides set up that will help you install the system. And here's an example of one. It's actually a snippet of one from our Schneider guide. And so some basic installation stuff without going into really intensive detail. Here is an example of a real neat installation. You can see the leads of the batteries file neatly into a cable tray there, and then combine in that combiner box and then go into the Sunny Boy inverters. So one thing that you may want to keep in mind here is that some of these cables, so they're all supposed to be of identical length and gauge, as we mentioned. So that means the batteries closest to that combiner box are going to have the most slack in it. So typically what you can do, I mean, if you're not using a cable tray or something like this, and even if you are, you can zip tie them. That's perfectly fine. But again, just as long as the idea is to keep all the conductors of equal length. So we mentioned no ventilation requirements. So so what you're seeing there is an attic stuffed with batteries, and they're jam-packed together. And in this case, they're using our wall mounts. And as we mentioned earlier, they can be installed in any orientation. So it is possible to use bus bars, as you can see in this photograph here. The batteries are lying on their side, so you just want to be, if you're going to do this type of installation, you want to make sure you size those bus bars correctly. Their ampacities are based on their dimensions or their cross sections. So it's important to check your guide or speak with someone to make sure that you're sizing those correctly, and make sure there's no impedance or resistance in the batteries. Should they be sized correctly, you won't have that problem. So once again, they do not emit, the batteries don't create gases or vapors. And I touched on this a moment ago, but the cabling is wrapped and cable tied here using zip ties. It's hard to see in the photo, but trust me, they're there. And here's an example of a bank of batteries with Outback Radiant inverters, and you can see some stacking going on here. You can see 2 inverters and 2 charge controllers and multiple batteries. So we're just about coming to the end here. I'll keep this up on the screen, so different ways to get in touch. Wholesale Solar, one thing that's awesome about them is that they're super technically savvy and market savvy, and they have a tech team that can help you with your questions. So there is their contact info, and if you're not a dealer yet, definitely sign up via that link. So that just about does it. If you guys have any questions, let me push it to Josh real quick if you want to come on the line. Was there anything else that you wanted to add? And Lisa too? All right. Well, let me check the chat here. So there's a lot of questions that came in. Josh, I'm just going to check real quick to see if you're muted. I think you may have wanted to say something there. Hey, Josh, you're off mute right now. So not sure why that keeps happening. Is there anything you wanted to chime in with?
Yeah, I just wanted to say, we can supply the access systems, which are plug and play all in one, or mainly what we're selling is the actual individual batteries. And then we can help design that into a system with Outback, Schneider, Magnum, Midnight, any of the major brands. Ricky, it looks like there's a couple of questions, one from Alden and one from Andrew Perkins in the chat that I'm hoping you can answer. I wasn't sure about the answer on those two.
What are their names? I'll try to find them. Or do you know the question offhand? The one thing that's difficult with this format. Oh, Josh, sorry, I don't know why I keep putting you on mute there,
oh, no worries. Andrew Perkins was asking, how do you restart the batteries when they shut down from low depth of discharge?
There's a couple ways of doing it. If you probably want to make sure that the battery is cycled off at that point. And there are some, if the battery is not taking a charge, you might want to look into some external chargers for it. But typically you want to do some voltage testing, make sure that the voltage is kind of meeting up to our specs, and charge the battery that way.
Ricky, is the recording going to be available?
We are recording it, yeah.
Great. Okay, so we can send that out to everyone who registered.
Sounds great.
Was there a second question there?
Alden was asking about charger set points for the solar charge controllers. Do you know like the float and absorb set points offhand?
Offhand, no. I mean, they're all in our integration guides for the float and the bulk. So you're approximately because the voltage remains steady, but it's generally somewhere between 56 and 57 volts for float and for float we don't float. There's no float on our batteries, but bulk and absorb. It's not like a lead acid where you have to do float charges, but the bulk and absorb are roughly around 56 to 57 volts.
Okay, what is the self-discharge? How long can they be stored, and how do you store them long term?
Yeah, so it's less than 1% a month. So they can be stored, for a few months without any problems charging them up.
Okay, great. And Brian Summers is asking about monitoring data collection. A lot of the inverters are going to have, monitoring and data logging capabilities. Same with charge controllers. Are you relying on the inverters and controllers to do that work, or is there anything in SimpliPhi that can be accessed?
Yeah, it's a great question. So we don't have any comms on our batteries. We just have the, positive, negative terminal and a BMS. So again, it's just the simplified way of doing it, pun intended. So we don't, so the comms we do have rely on third parties for comms. We're looking to integrate more comms into our systems. But at this point, it's actually we found it's been kind of a benefit not to have all these kind of difficult to install internet-based comms that some of the other competitors use. So yes, the short answer to your question is that state of charge, other metrics like that have to be done via third-party equipment.
Okay, that sounds good. Well, it looks like that's most of the questions. Thanks a lot, everyone, for attending.
Thank you.
All right. Yeah. So thanks again for attending. I still see on your screen the ways to contact Wholesale Solar. And yeah, if you guys have any questions, shoot them an email or a call, and we're happy to help as well. All right. So that concludes the presentation. Thank you very much.
Thanks, Ricky.
So the one guy was, Mike and Maria.
Got some good thanks privately.